Imagine someone hands you $100 bill. You can feel it, fold it, lock it in a safe. Now imagine someone sends you Bitcoin. There's no coin. There's no file on your computer labeled 1 Bitcoin. There's no object anywhere. What do you own? The answer involves ideas so clever they've been running without a single hour of downtime since January 2009. No CEO, no headquarters, no off switch. Let's break down exactly how that works. To understand what you own, start with what Bitcoin is and what it isn't. Two meanings hide behind one word. Capital B Bitcoin is the network, the protocol, the system, thousands of computers running it worldwide. Lowercase b Bitcoin is the currency, the unit of money that moves across that network. Here's the crucial insight. Bitcoin isn't a digital file. There's no MP3 of money sitting on a hard drive. Coins are implied by transaction records on a shared ledger. When Bitcoin moves from one person to another, the ledger updates. That's all. People use Bitcoin to buy goods, send money across borders, and trade for other currencies. Think of it as the internet's native money. Fast, borderless, open to anyone with a phone. In traditional finance, a bank holds your money and the database says it's yours. Bitcoin eliminates the bank entirely. Ownership comes from cryptographic keys, mathematical tools that prove control over funds without any institution. Every Bitcoin user has two pieces, a private key and a public key. The private key is your secret signing key, a long string of characters that proves ownership. Think of it as a password that's mathematically impossible to guess. The public key, derived from the private key, works like a mailing address. Share it freely. Others send Bitcoin to it. When you spend Bitcoin, you create a transaction, a signed message saying, I transfer this amount to this address. Your private key signs that message. The network verifies the signature. No bank approves it. No ID required. This is the fundamental rule. Whoever holds the private key controls the Bitcoin. Not your keys, not your coins. Your key proves ownership. But who verifies the transaction and keeps the ledger honest? Miners. Mining is a computational competition that secures transactions and creates new coins. Roughly every 10 minutes, a miner somewhere in the world completes 3 steps. First, they bundle recent pending transactions together. Second, they race to solve a computationally intensive puzzle referencing those transactions. Third, the winning miner adds that bundle, called a block, to the chain of all previous blocks. That chain is the blockchain, a public append-only ledger of every Bitcoin transaction ever made. For this work, the winning miner earns a reward, newly created Bitcoin plus transaction fees paid by senders. This single process replaces 2 functions a central bank normally handles, like issuing new money and clearing transactions. No committee decides. The math decides. Mining creates new Bitcoin, but how much and for how long? This is where Bitcoin's economic design gets truly elegant. 2 built-in mechanisms control the supply. First, the difficulty adjustment. The mining puzzle automatically gets harder or easier so that blocks arrive every 10 minutes on average, regardless of how many miners are competing. If half the world's miners quit tomorrow, the puzzles get easier and blocks still arrive every 10 minutes. More computing power means more security, not faster coin creation. Second, the halving. Roughly every 4 years, the mining reward is cut in half. It started at 50 Bitcoin per block in 2009. Then it dropped to 25 in 2012, then 12.5 in 2016, then 6.25 in 2020. And today, after the 2024 halving, it stands at just 3.125 Bitcoin per block. This creates a predictable diminishing issuance curve. Look at the chart. The total supply rises steeply at first, then flattens out as the rewards shrink. By approximately 2035, around block 1,411,200, 99% of all Bitcoin will have been issued. Let's verify. 99% of 21 million is 20,790,000. After 6 halving epochs by 2032, about 20,671,875 Bitcoin exist. That leaves about 118,125 more to reach 99%. At a reward of 0.78125 Bitcoin per block, that takes about 151,200 blocks, landing us right around 2035. The hard cap stands at just under 21 million coins, specifically 20,999,999.9769 Bitcoin ever. No one can print more. The final Bitcoin won't be mined until approximately 2140. Bitcoin is deflationary by design. Compare this with traditional banking. A central bank like the Federal Reserve issues money with no hard cap. The supply can always expand. Banks validate transactions during business hours. Your ownership proof is an account in your name at an institution. You need permission to participate. And the system depends on central servers that can fail. Bitcoin inverts every one of those properties. Protocol rules control issuance with a hard cap near 21 million. A decentralized network validates transactions 24/7, 365. A cryptographic key proves ownership. Not an institution, no permission needed, no single point of failure, running non-stop since January 2009. The keys, the mining, the fixed supply, all of this works because 4 innovations operate together. First, a peer-to-peer network. Thousands of computers called nodes run the Bitcoin software worldwide. No central server, no single point of failure. Second, the blockchain, a public, tamper-proof ledger of every transaction ever made. Anyone can verify it. No one can alter past records. Third, consensus rules, a shared rulebook baked into the software that every node enforces independently, defining valid transactions, coins per block, and halving schedules. Fourth, proof of work. The computational puzzle miners solve. It makes cheating economically irrational. To rewrite transaction history, an attacker would need more computing power than the entire rest of the network combined. These aren't 4 separate features. They're interlocking gears. Remove anyone, and the machine breaks. Step back and see what these pieces solved. For decades, computer scientists struggled with a core problem. How do strangers on the internet agree on who owns what without trusting anyone? Bitcoin's answer: combine cryptographic proof of ownership, an open ledger anyone can audit, rules enforced by code rather than institutions, and an economic incentive, mining rewards, that keeps participants honest. The result is a system where no single party can cheat, censor, or inflate the money supply. Not a government, not a corporation, not even Bitcoin's pseudonymous creator, Satoshi Nakamoto, who published a 9-page paper in 2008 and disappeared, leaving the network to run itself. Bitcoin isn't just digital money. It's a protocol for transmitting ownership and trust through distributed computation. 0 downtime, 0 employees, 0 central authority for over 15 years. This architecture, trustless, decentralized, permissionless, extends far beyond payments. It's a blueprint for rethinking any system that depends on centralized trust. And it started with a 9-page paper, a pseudonymous author, and one radical idea: math can do the job we've always needed institutions for.